Hello dear students, welcome in our video lecture of Redox reaction. In previous video we have discussed about the rules to find out the oxidation number of an element in a species. Now in this video we are going to learn some examples and we will learn how to find the oxidation number of an element from a compound by using the rules which we have already discussed. The link you will get by pressing the I button. Okay, so take your note and pen with you and let us start. Okay, so let us start with HCl. Now we will memorize the rules also. The first rule was the oxidation number of an element is always 0 or a neutral molecule's total oxidation number is always 0. So here we have HCl and we are asked to find what is the oxidation state of chlorine in HCl. So HCl is a compound which is neutral, so its total oxidation number will be considered as 0. So in that case we have to write HCl is equal to 0. Now we want to find the oxidation number of chlorine. So for that we must have the knowledge of oxidation number of hydrogen in this compound. Now if you remember the rule, then there was a rule which states that hydrogen can have +1 or -1 oxidation states in its different compounds. So here we have hydrogen, and what will be its oxidation number? Either it can be +1 or -1. So the subtopics of that rule was if hydrogen is attached with electronegative element like chlorine, chlorine, bromine, iodine, oxygen, nitrogen, etc., then the oxidation state of hydrogen should be considered as plus. But if hydrogen is attached with electropositive element like metals, in that case the oxidation state of hydrogen should be considered -1. So here, what is attached with hydrogen? So it is chlorine. Chlorine is an electronegative element, therefore oxidation state of hydrogen is considered as +1. So let us write oxidation state of hydrogen, that is +1, plus oxidation state of chlorine that we are going to find. So let us consider it as X is equal to 0. Now if we make subject X, then X is equal to this +1 will go to the opposite side of the equal to, so it will become -1. So here the oxidation state of HCl in this compound, the oxidation state of chlorine in HCl is -1. Okay, now let us take another example. H2O, and we are asked to find the oxidation state of oxygen. So here H2O is also a neutral molecule. So the total oxidation state of H2O is considered as 0. And if we want to find the oxidation state of oxygen, then we have to write the oxidation state of hydrogen according to the rules which we have discussed in our previous video. And again, hydrogen is attached with oxygen. Oxygen is an electronegative element. Then again, the oxidation state of hydrogen is considered as +1. So here this hydrogen is having +1 oxidation state, but we have two such kind of hydrogens. So 2 multiplied by +1, that is the oxidation state of hydrogen, plus oxidation state of oxygen is X is equal to 0. Now 2 into +1 will give us +2, plus X is equal to 0. In that manner, X will be equal to this 2 will go to the other side of equal to, so it will become -2. So here in water, oxidation state of oxygen is -2. It is as simple as that. Okay, now let us take the third example, NH3, and we are asked to find the oxidation state of hydrogen. Again, it is a compound in which hydrogen is present. And what will we do? Hydrogen is attached with nitrogen. Nitrogen is an electronegative species. Electronegative, that means situated on the right side of the periodic table. Therefore, the oxidation state of hydrogen should be considered as +1. Again, being a neutral species, NH3 is equal to 0. And if you want to find the oxidation state of nitrogen, then let us consider it as X plus 3 multiplied by plus 1, that is the oxidation state of nitrogen. So X plus 3 is equal to 0, so X will be minus 3. So here the oxidation state of nitrogen in ammonia is minus 3. Now let us consider example MgH2. Now if we want to find the oxidation state of magnesium, the oxidation state of magnesium is fixed, that we will discuss. But now here we are going to find the oxidation state of magnesium. Okay, hydrogen is attached with magnesium, and if hydrogen is present, then we have to think about whether the compound with which hydrogen is attached is electronegative or electropositive. So first of all, magnesium is a metal, that means it is situated left in the periodic table. And as metal is attached with hydrogen, in that condition, the oxidation state of hydrogen should be considered as -1. When hydrogen is attached with any metal, in that case, oxidation state of hydrogen is always considered as -1. So let us count MgH2 is equal to 0. We are going to find the oxidation state of magnesium, so consider it as X plus 2 multiplied by, now here the oxidation state of hydrogen is taken as -1. In the previous examples, the oxidation state was taken +1 because in all these three examples, hydrogen was attached with electronegative element. But here it is attached with electropositive element, that is metal. And when hydrogen is with metal, then its oxidation state is always -1. Okay, so X 2 ones are 2, and the sign will be -2 is equal to 0. If this -2 goes to the other side, then it will become +2. So here the oxidation state of magnesium is +2. Now from today, let us remember one more. This is our periodic table, and here we have two groups, group 1 and group 2. This group contains lithium, sodium, potassium, rubidium, cesium, and calcium. And group 2 contains beryllium, magnesium, calcium, strontium, barium, and radium. Barium Ba and radium R. Now, take this thing in your mind. If you see any element from group 1, then their oxidation number in any compound will always be +1. So, oxidation number of all elements situated in first group contains +1 oxidation state in all their compounds. So this all will have always +1 oxidation state. And the element which is situated in the second group will have always +2 oxidation state in their compounds. So if you see any element in a compound from group 2, then their oxidation state will always be +2. If they are of group 1, then their oxidation state will always be +2. So this thing you have to remember. So here magnesium, which is a group 2 element, and therefore its oxidation state is +2. Now let us consider some more examples. So here all these four molecules were neutral, but let us take a charged species like this, SO4 -2. This is sulfate ion, and if we are asked to find the oxidation state of sulfur, then what will do? So first of all, as this is a charged species, so we have to write the charge after the equal to sign, that is. If molecules are neutral, then equal to 0. But if molecule is having a charge, then we have to write the charge equal. Now, if you want to find the oxidation state of sulfur, then consider it as X plus 4 multiplied by, here we have oxygen. What will be the oxidation state of oxygen? So in normal condition, oxidation state of oxygen is always -2. In most of the, there are some compounds with which oxidation number of oxygen is -2. We will discuss about that, but here, right now, the oxygen is a normal oxygen, therefore its oxidation state is -2 is equal to -2 as it is. Now x, 4 2s are 8, and here we have minus sign, so it is -8 is equal to -2. So x is equal to -2. If this -8 goes to the other side, then it will become +8. Now +8 minus 2 will give us +6. So here in SO4 minus 2, the oxidation state of sulfur is +6. So this is the oxidation state of an element in a charged species. Now let us take one more charged species. That is CO3 minus 2. This is carbonate ion. And if we want to find the oxidation state of carbon, then again CO3 minus 2 will be equal to -2. Why? Because the total charge over here is -2. Now X plus 3 multiplied by oxidation state of oxygen is -2 is equal to -2. So X 3 2s are 6, and having a negative sign, it will become -6 is equal to -2. Now this 6 goes to the other side, so it will become +6. So X is equal to -2 plus 6, then X will be +4. So here in carbonate ion, the oxidation state of carbon is +4. So this is the method, simple method to find out the oxidation state of any element in any species, whether it be neutral or charged. So just pause the video, write down all these examples, then after we will see some more examples. So now the 7th example. The 7th example is H2SO4. Now this is sulfuric acid, and we are asked to find the oxidation state of sulfur. Then what will be? Okay. So once again, this is a neutral species, therefore H2SO4 will be equal to 0. Now, if we want the oxidation state of sulfur, then we must have the knowledge of oxidation state of both these elements. Now here again hydrogen and oxygen. Oxygen will always considered as -2, and hydrogen, here all the non-metals are there. We will learn the structure of sulfuric acid also in chemical bonding and molecular structure chapter. But here, oxygen is attached with hydrogen is attached with oxygen. That means hydrogen is attached with electronegative element. Here all elements are electronegative. That means non-metals. Therefore, hydrogen's oxidation state is considered as +1 over here. 2 multiplied by +1 for hydrogen plus X, that is for sulfur, plus 4 multiplied by -2, that is for oxygen, is equal to 0. Now 2 1s are 2, that is +2 plus X, 4 2s are 8, but it is -8 is equal to 0. So -8 plus 2 will give us -6, and if that -6 goes to the other side of equal to, then it will become +6. So again the oxidation state of sulfur in sulfuric acid is +6. In sulfate it was +6, and in sulfuric acid it was +6. Both these are same. Here SO4 is -2, but if I attach 2H plus with it, then it will become H2SO. So both are same. Okay, one more thing. If I write H2SO3, this is sulfuric acid. And if we are asked to find the oxidation state of sulfur over here, then what will be? So again, H2SO3 being a neutral species, so the total oxidation state will be 0. Now 2 multiplied by oxidation state of hydrogen is +1 plus for sulfur, we will write X plus 3 multiplied by oxidation state of oxygen -2 is equal to 0. 2 ones are 2, it is +2 plus X, 3 2s are 6, but it is -6 is equal. So -6 plus 2 will give us -4, and that -4 it goes to the other side of equal to, then it will become +4. So here in H2SO3, the oxidation state of sulfur is +4, but in H2SO4, oxidation state of sulfur is +6. So these are some simplest example to find out the oxidation state of an element from. But these are the simplest examples. Still, we are going to learn more examples, which can be a slightly complicated. But before that, let me give you some examples which you have to do in your home. So this is your home. Find out the oxidation state of underlying element. The homework is, suppose if you are asked to find the oxidation state of nitrogen in HNO3, then find the oxidation state of H3PO4, phosphorus in H3PO4, and H3PO3 again, the oxidation state of phosphorus, and Fe H3, and find the oxidation state of iron in FeH. So these are the examples which you will solve in your homework, and you will give the answer in comment section. If you have any doubt, then also you can write your doubts in the comment section after this video. So in this video, we have seen only 8 examples to find out the oxidation state of an element. Still, we will make one more video on oxidation state. And in our next video, we are going to see some different kind of things, or the oxidation state of elements which are not normal. They are some kind of special or abnormal. So that we will see in our next video. So that's all for today's video. If you like the video, then press the like button. Share this video among your friends. And these videos are for all students, open for everybody, for all the students which are studying in 11th and 12th science. I am not making my video unlisted. They are public. So anybody can see, watch and learn from these videos. So I need your favor, and that is share this video. Ask your friends to subscribe my channel. If you subscribe my channel, then there at one day I will have some kind of ads in my video. So it will be beneficiary to me, but after a period of time. But as these videos are for all students for free, so you are getting benefit, right? And you will get benefits in videos. So in that manner, request you to subscribe my channel, share this video among your friends, and make other to subscribe this. Okay, so till we meet next time.